Okay, so let's proceed with the principal stress and maximum in plane shear stress. Okay, so what is the principal stress? Okay, so principal stress is the maximum and the minimum of normal stress. So basically we are going to define what is sigma 1 and sigma 2, where sigma 1 will be the largest value. Okay, so so this is maximum and minimum normal stress. Okay, and then the maximum in plane shear stress. Okay, for both of these stress components you have to determine at what orientation. That's mean, okay, for the principal stress, at what angle, at what orientation that maximum normal stress will occur. And for this one we call it as theta p. Okay, and then for the maximum in plane shear stress, you also needs to know at what angle that will cause the maximum in plane shear stress will occur. Okay, so here you are going to determine what is theta s. Okay, so and then it is important to note that when the state of stress is represented by the principal stress, okay, so there will be no shear stress acting on the element. Okay, so let's say here you are having sigma 1 and sigma 2, which is the maximum, which is the principal stress. Okay, so here there will be no shear stress acting on this element. Okay, and then on the plane that the maximum in plane shear stress occur, there is also an average normal stress acting on the plane. Okay, so here let's say at this rotation, at this angle, you obtain what is the maximum shear stress. Okay, the maximum in plane shear stress, and here there will be an average normal stress acting on the plane. So here you are going to have sigma average, and this here also you will have sigma average. Okay, so how to find the principal stress and the maximum in plane shear stress? So we are going to differentiate the transformation equation, which is equation 1 and equation 2. Okay, so I will show you how to derive the equation to obtain the principal stress and maximum in plane shear stress in the next slide. Okay, so let's start with the in plane principal stress. Okay, as I said just now, we are going to differentiate the equation number 1. Okay, so we know that this is the equation number 1. Okay, and then you have to differentiate it with respect to theta. Okay, so we are going to differentiate this equation with respect to theta. So you will have this equation. Okay, so now you have d sigma x prime divided by d theta with derivation with respective to theta, and then you will get this. Okay, so this one will be terminated, and then differentiate cosine, you will get negative sign, so that's why you have negative and sine 2 theta here, and then differentiate of sine theta, will get cosine theta, so here you have 2 tau xy cosine 2 theta, and then you must make it equals to 0. Okay, so d sigma x prime over d theta must be equals to 0. Okay, and then rearrange this equation, you will get like this. Okay, this one you put it on the left side, and this one is maintained in the this one is on the right side, and then you rearrange the equation, you will get in this form and also in this form. Okay, so now you have sine 2 theta over cosine 2 theta is equals to tau xy divided by sigma x minus sigma y divided by 2. Okay, so we know that sine over cosine is tangent. Okay, so now we have tangent to theta p. Okay, so theta p is by referring to the principal plane. Okay, so you will have tangent to theta p is equals to tau xy divided by sigma x minus sigma y divided by 2. Okay, so this is equation number 4, and this equation you will get two roots, which is theta p1, 2 theta p1, and also 2 theta p2. Okay, if you divide by 2, and then you will get what is theta p1 and theta p2. Okay, so this equation can be illustrated by this figure. Okay, so tangent to theta p, so this is the angle 2 theta p, and we name it as 2 theta p1 because we have two roots, right? We are going to have theta p1 and theta p2. Okay, and then we have tau xy, which is this one, tau xy, and we have sigma x minus sigma y divided by 2, and this is sigma x minus sigma y divided by 2, and then the angle from this plane, which is stress sigma axis, to this one is 2 theta p1. Okay, so what is 2 theta p2? 2 theta p2 is, okay, so 2 theta p2 is, so this is equals 180 degree plus 2 theta p1. Okay, so this is, as you can see here, denoted by the red the red line. Okay, so this is 2 theta p2. Okay, so once you already obtain what is theta p1 and theta p2, so you can substitute this value into equation 1. Okay, so you can substitute it into equation number 1 in order to obtain the principal stress, which is you are going to determine what is sigma 1 and sigma 2. Okay, so this is equation number 1. Okay, so you have to substitute this theta into this equation, and then you will get, let's say we denote it as theta, sigma 1. Okay, so sigma 1, and then you will get the equation into like this. Okay, so you can rearrange this one and you will get into like this. Okay, so to simplify this, so you can see in this diagram, in this figure, so we have this triangle shape. Okay, so now we know that this is tau xy, and this is sigma x minus sigma y divided by 2, and the angle in between here is 2 theta p1. Okay, so this is 2 theta p1. Okay, so we denote the hypotenuse plane is r. Okay, so how to find r? R square is equals to this one, square of this one plus square of tau xy. Okay, so like this, and then based on this figure, we know also cosine 2 theta, which is cosine 2 theta p1, is also equals to adjacent, which is sigma x minus sigma y over 2, okay, divided by r. And then we know what is the sine 2 theta here, which is sine 2 theta p1 is also equals to opposite to the angle, which is tau xy, divided by hypotenuse plane, which is r. Okay, so we can use these three equations to simplify the equation, to substitute and simplify this equation. Okay, so you will get the answer, you will get the equation like this. So you will get the equation like this, and then you simplify it again, and you will get sigma 1 is equals to sigma x plus sigma y over 2 plus, okay, so this is plus square root of sigma x minus sigma y over 2 square plus tau xy square. Okay, so next let's determine what is sigma 2. Okay, let's proceed to the next slide. Okay, so we know that sigma 1 is larger than sigma 2. Okay, so we already know what is sigma 1. So to get the smaller principal stress, which is sigma 2, we can use this equation, which is sigma 1 plus sigma 2 is also equals to sigma x plus sigma y. And then sigma 1, you bring the sigma 1 into this side, and then you will get sigma 2 is equals to sigma x plus sigma y minus sigma 1. Okay, so you already know what is sigma 1, so you can substitute the equation of sigma 1 into this, okay, for the sigma 1. Okay, so you will get this equation, and then you simplify this one. It is like 1 minus 1 over 2, okay, is equals to 1 over 2. So here now you have 1 over 2 of sigma x plus sigma y minus square root of sigma x minus sigma y over 2 square plus tau xy square. Okay, so this is the value, this is the equation for sigma 2. So you can make it into like this. Principal stress sigma 1 and sigma 2 is equals to sigma x plus sigma y over 2 plus and minus. So that's mean sigma, for sigma 1 you have to use plus, for sigma 2 you have to use minus this. Okay, so this one is equation number 5. Okay, so now let's move to the maximum in-plane shear stress. Here we are going to determine what is the theta s. Okay, so at what angle the maximum in-plane shear stress will take place. Okay, so in this for this one you are going to use equation number 2 and differentiate with respect to theta. Okay, as like this. So you have the theta x prime y prime, differentiate with respect to the theta. Okay, and then differentiate sine theta, you will get cosine theta. So negative will be maintained here, and then for differentiate cosine you will get negative sine theta. So that's why you have minus here, and then sine theta here. Okay, and then we make it equals to 0. Okay, and then rearrange the equation, and then you will get like this equation. Okay, and then by doing sine over cosine, okay, sine over cosine, you will get tangent to theta s here, and then is equals to negative sigma x minus sigma y over 2 divided by tau xy, and this is equation number 6. Okay, So this equation can be illustrated by using this figure. Okay, now we know that, so now we have negative sigma x minus sigma y over 2. Okay, so this is sigma x minus sigma y, okay, negative sigma x minus sigma y over 2, and this is tau xy. Okay, so the angle from tau axis into this inclined plane is 2 theta s1. Okay, so this is 2 theta s1, and same as like in principal plane. Okay, how to get 2 theta s2? So 2 theta s2 it must be 180 degree apart. Okay, so it is equals to 100 plus 2 theta s1. Okay, so you know how to calculate theta s1 and theta s2. Okay, and then substitute the roots that you get from the equation number 6, okay, which is 2 theta s1 and 2 theta s2. So you have to substitute it into equation number 2, which is for the shear stress in x prime y prime axis. So then you can obtain what is the maximum in plane shear stress. Okay, so you substitute this angle and you will get like this equation. Okay, so as you can see from this figure, so I will simplify it. Okay, I will show you how we can get what is the tau maximum in plane. Okay, so we have this triangle. Okay, so we have this triangle, and then we have negative sigma x minus sigma y over 2 here, and then we have tau xy here, and then the angle from tau xy axis to the horizontal to the inclined plane is represented by 2 theta s1. Okay, so you have to find what is the r value. So r square is equals to tau xy square plus sigma x minus sigma y over 2 square. Okay, so this is negative, but if it is square, so it become positive, so that's why it's positive here. Okay, so find what is the cosine theta. Okay, so what is the cosine 2 theta s1? So for cosine, it is, so cosine for this angle, it is equals to adjacent, which is tau xy, divided by the hypotenuse, so divided by r. And then for sine theta, okay, so for the sine theta, you have we have opposite, which is this one, divided by the hypotenuse. Okay, so we have negative sigma x minus sigma y over 2. Okay, so this is over 2, and then divide by r. Okay, so we have this one, and then these three equations we can substitute it into this equation. Okay, so then you can get, like, you can simplify it, and it can becomes so this is r square. Okay, so we can simplify it and we can become r. So r is equals to square root of tau xy square plus sigma x minus sigma y divided by 2 square. So this is the maximum of shear stress. Okay, the maximum in plane of shear stress, and we represent this one as equation number 7. Okay, so as I said, when you get the maximum in plane shear stress, you also need to find out what is the sigma average, because sigma average also occur in the plane where the maximum in plane shear stress occur. Okay, so for this one you have to substitute the theta S1 and theta S2 into equation number 1. So this is equation number 1. So you have to substitute 2 theta S1 and 2 theta S2 into this equation, and then you will get like this equation. Okay, so you can eliminate this one and also this term, and you will get what is the sigma average. So it is equals to sigma x plus sigma y divided by 2, and this is equation number A.